This evening we're going to talk about Azure Durable Functions. Now, I don't know how many of you know about Azure Functions or have used them. So a few of you. Okay. So what I thought we'd do would be to start off just with a bit of an overview of Azure Functions, and then we'll get into what Durable Functions adds to that later on. Just to introduce myself, I'm actually local. Been coming to this user group for a while. I work for a company called Nice. I also make a number of courses for Pluralsight. 4 of them are on Azure Functions. And in fact, one of the ones I recently published, which is called Azure Developer Create Serverless Functions, is part of the new Microsoft Learn initiative, which means that you can watch this for free even if you're not a Pluralsight subscriber. So if you'd like a kind of an introduction to Azure Functions that takes you through all the basics, then go via the Microsoft Learn website, and that will enable you to access that. I've also been coming to this user group for quite a while. I looked up in my email inbox what my first session at this user group was, and it's from November 2007. I came to Visual Studio 2008 and .NET 3.5, which was the second ever. It wasn't called Dev South Coast, it was called Next Gen User Group. But as you can see, some things never change, pizza and swag. And the reason I wanted to show this slide was not to brag about how long I've been coming, but I thought it'd be, I wanted to say thanks to John and Richie for running this group for such a long time. I've really enjoyed being part of it. And I know they had an announcement last week about planning to hand it over, but it's been an impressive long innings. So well done to you guys, and hopefully we'll find the right people to take the group forwards long into the future. So Azure Functions. One of the questions that may arise when you think about something like Azure Functions is, why on earth do we need another way to run code in the cloud? So there are already many different options that you can take. If you've got an application that you want to run and host it in Azure, you can go the kind of traditional IaaS approach, where you provision a virtual machine. You can install whatever you like onto that virtual machine, be it websites or Windows services or Linux in any language. And that was very much the standard way that we would get code running in our data centers or in the cloud traditionally. However, we're seeing a shift away from pure IaaS at the moment because of the ops overhead involved in that. There's when you spin up a virtual machine, you've got to maintain it. You've got to make sure the operating system is patched. You've got to make sure that it's still running. And so we've seen a move away from IaaS towards PaaS, Platform as a Service. And Azure's got a few different PaaS offerings. Their kind of premium one is what's called Azure App Service, which allows you to easily run your web applications, and they can be in a variety of different programming languages. They can be, as you'd expect, .NET, but you can also use Node.js, PHP, Python, Java, all the kind of usual ones. And Azure App Service also supports this concept of web jobs, which is for your long-running background tasks. So things like you want to listen to messages on a queue, or maybe you've got scheduled background jobs that you want to run. And also, even more recently, we've seen the meteoric rise of containers. So I don't know how many of you played with Docker at all. Okay, how many of you are using Docker in production? Okay, not so many. I mean, it is still relatively new technology, but all of the cloud vendors are really adopting it and offering you many ways of running containers. And Azure's got several services, whether you just want to quickly spin up a single container with ACI, or you want to have a full Kubernetes cluster with AKS. There's lots of ways to run containers. However, Azure Functions fits into a slightly different category of running code in the cloud, which has become known as Functions as a Service, or Serverless, which we'll talk about in a minute. And a number of the major cloud providers have got different Functions as a Service offerings. I think Amazon were the first with Lambda, but Google have got them. I think IBM's one is OpenWhisk or something. And really all a Functions as a Service platform is, it's a managed platform that you provide your code in the form of simply a function, so it's quite a small unit of deployment, and you say that I want my function to run in response to some kind of event. So it's event-driven programming in the cloud. And these events are known as triggers. And so here's an example of some of the triggers that Azure Functions supports. So one of the triggers is a HTTP request. And this is particularly flexible because that means you can use Azure Functions to implement web APIs. So you could say when a GET request comes in on this endpoint, I want to run this function. And when a POST comes in on this other endpoint, I want to run a different function. It's also very popular for setting up webhook listeners. So if you've got an external system that provides webhooks to tell you about interesting things, for example, GitHub produces webhooks, Slack produces webhooks. It's very easy to create a simple Azure function to host your code that is going to run in response to that webhook. But it's not just about HTTP requests. You can also implement scheduled functions in Azure Functions, so you can have a timer trigger. You can also listen on queues. So again, if you want to implement your asynchronous tasks by listening on queues, and we'll be talking quite a bit more about that later this evening, you can do that. But it's also got lots of integrations with other systems. So for example, Azure Blob Storage, where you can store files, you can say, whenever a new file gets uploaded to Blob Storage, I want that to trigger a new function. Or Cosmos DB, which is one of Azure's document databases. You can say whenever a document is added or updated in Cosmos DB, I want that to trigger a function. Now, the unique selling point of Functions as a Service platforms is what's known as serverless. And serverless, again, is a buzzword that has risen in popularity over the last few years, is criticised because, spoiler alert, there are actually still servers. But the way I see serverless is there are three kind of big ideas to it. First of all, you don't want to manage the servers yourselves. They're completely abstracted away from you. So when you run Azure Functions, you don't have to worry about what versions of the operating system they're running. The servers are just there in the background. But secondly, there's automatic scale. So when you provision Azure Functions, you're not kind of picking a size, small, medium, or large. Azure Functions is going to automatically scale to meet your demand. So if you had a function that was triggered by a HTTP request, for example, and you found that that function was getting loads and loads of traffic, Azure Functions would very quickly spin up, and it does spin up very quickly to, say, 100 servers in the background, all processing those requests to help you meet dramatic spikes in load. Similarly with queue listening functions, if you say this function is processing messages from this queue, and you drop 1 million messages into that queue, again, Azure Functions is going to spin up very quickly to up to, say, 100 servers to help you burn through that queue as fast as possible. Obviously, you've got to be careful that you don't denial of service some downstream system because you've now got so many servers working on it. But this is one of the really attractive things about serverless. Scale is automatic. You can start small and then it will just scale out to meet the demands that you have. And the third key idea behind serverless, and this is one of the things that really sets it apart, with all those other ways of hosting your code in the cloud that we've talked about, you typically pay on a kind of rent compute resources for a month approach. So if I've got a virtual machine, I might be paying, depending on the size of the virtual machine, £30 a month or £100 a month to have that virtual machine available to me, and I'm paying that whether it's working hard or not. And the same is actually true with a lot of the platform as a service, or if you've got a Kubernetes cluster, you're paying for the nodes in your cluster, whether they're doing anything or not. With serverless, you are only paying while your function is running. So if your functions don't run for a month, you actually pay nothing at all. And one of the great benefits of this is that it allows you to essentially, if you're creating a new application, you're just prototyping, you've just got an idea, and you've only got a very small amount of usage, you're paying virtually nothing at all. And it's only when you start to get serious amounts of usage that you have to pay. So just a quick look at the pricing model. You pay 15 pence for 1 million function executions, and for each second that your function is running, you run you pay some very small fraction of a pound. But you'll also notice in the far right column there that you get a monthly free grant. So what that basically means is that every month you're allowed to execute 1 million Azure Functions for free, and they can run for up to 400,000 seconds essentially for free. And so if you're just wanting to experiment and play with Azure Functions, it's very unlikely that you'll pay anything at all. It's only when you start to hit serious usage. Now, one of the criticisms of serverless that you sometimes hear is that the function, some people talk about functions as a service as being nano services, because you're deploying these really tiny packages of code that are essentially just a single function, that's almost too small a unit. So if I've got loads and loads of functions, do I want to be separately developing each one in its own source control repository and deploying it all individually? That seems like a lot of overhead. And Azure Functions actually has got the concept of what's called a function app. And this is kind of a way of grouping together a bunch of functions that logically belong together. And so when you have functions in a function app, they share common configurations. So if you've got connection strings, they can all access the same connection strings. You deploy them as a group, and they will also scale as a group. So if one of those functions is having to do a lot of work, then essentially all of them will get scaled up to the same number of servers. And if you know anything about Azure App Service, which is actually the underlying platform that Azure Functions runs on, then an Azure App Service has the concept of an app service plan, and you can run many function apps on the same app service plan. Now, let me just jump out of my slides. I'm not going to spend a long time talking just about Azure Functions, but just to give you an idea of what an Azure Function looks like, this is an example of a scheduled function. One of the interesting things with Azure Functions is you're not limited to just C#. You can create Azure Functions in several different languages. Probably the best two supported are C# and JavaScript, but they've also got Python support, they've got Java support, which is fairly new, and you can obviously use other .NET languages like F# as well if you want to. And if you are writing them in C#, this is what your code would typically look like. Each function is a static function, and it's got some attributes that define how your function is triggered. So in this example, my function has a name just of scheduled function, and it has a timer trigger, which has got a cron expression saying that this function is going to run every 5 minutes. And Azure Functions also has the concept of bindings. So it tries to reduce the amount of code that you need to write to interact with other services. And so there are a lot of built-in bindings to help you deal with blob storage, queues, Cosmos DB databases, and so on. And so in this example, I'm using a table binding to say that I want to interact with an Azure Storage table. Azure Storage Tables is just a very cheap key value store type database. And I can just use a simple binding to connect to that, and it just cuts down on the amount of code that I need to write. And in this example here, this is an example of a HTTP triggered function. So you can see that I've decorated one of the parameters as a HTTP trigger. I'm saying that I'm using anonymous authorization. It's got support for kind of function keys to protect your endpoints. I'm saying I'm supporting the put verb, and you can customize the roots of your functions and so on. One really nice thing about Azure Functions is that the runtime is able to run locally on your local development machine. And so when I'm testing this, as you can see here, it's spinning up the Azure Functions runtime. Apologise that font is a little bit on the small side for you. This is running the exact runtime that would be running in the cloud. So you really are running the real thing. Obviously, in this example, the Azure Storage account that I'm connecting to, I'm not connecting to the cloud, I'm connecting to, there's an Azure Storage emulator. So there's the Azure Storage emulator. So what it's done, it's started up and it's detected a bunch of functions that I've declared in my project just by sort of scanning the assembly. And so you can see this is like a simple to-do app, so I can get the to-dos and delete them. And it's worked out from those attributes what HTTP methods they support, and the endpoint will be, so that put one, where's the put one that we were looking at there? It's going to listen on /API, which is just its default, /to-do, which we specified in that attribute, and then it will provide that ID to me as another parameter to my function. And so I'm hoping what I've done with this particular example, localhost 7071, I've actually got a user interface. This isn't obviously part of Azure Functions, but just calls those endpoints, so I can add items to my to-do list. And as you can see, as I run through them and I mark one as completed, that will call the, again, apologies, that's a small font size, it calls the update to do task, and so I can see all of this running through in the runtime. One other interesting thing about the fact that the Azure Functions runtime runs locally is that if you want to, you can containerize it as a Docker container. And so if you like the Azure Functions programming model, but you're not working in Azure, you can still use Azure Functions just by using a Docker container. One of the questions that I have with that Azure Functions is, although it's great for making little things like webhook listeners and listening on a queue, what happens when you start to want to implement some longer running business processes with a serverless platform? And so to give you a sort of idea of the type of thing that I work on in my day job at NICE is we deal with evidence for the police. So in criminal cases these days, there's a lot of digital evidence that the police have to deal with. They have to deal with crime scene photos that are digital photos. They deal with recordings of interviews with witnesses. A lot of police are wearing body-worn cameras, so there's a lot of footage of that. We also have the recordings of 999 calls and recordings of police radio conversations. And so there's just a large amount of digital evidence, and the systems that I'm working on are trying to help the police manage that and organise it and search it effectively. But also sometimes the general public might have some evidence that they want to upload and provide. So maybe somebody has captured on their mobile phone something taking place and they want to submit it. And if that was to happen, what we might do in our system is we'd let them upload it. They'd upload it through some kind of website. And because it's a member of the general public, we don't really trust what they're uploading, so we want to virus scan it. And then once we virus scan that, we will copy it out of a kind of a safe DMZ zone into our system. Then we might want to extract some metadata from that file. So a lot of videos have got details of what the date, time they were taken on and where the location was. We probably want to save it to our database. Auditing is really important, so keeping track of who uploaded this and when. And then, because the police use cutting-edge modern web browsers like IE8, we have to transcode it into a format that's playable on their web browsers. And maybe we have to transcode it into a few different formats, high res and low res and so on. Then we might extract a thumbnail image from it as a representative picture. And then maybe we want to do something fancy to take advantage of some AI and to do some kind of analytics on the video. Maybe we can detect car registration plate numbers. Maybe we can extract the voice and turn that into, transcribe it into text. And then finally, when all of that is done, we'd like to notify the detective that, hey, there's a new piece of evidence in your case that you might be interested in receiving. And I've drawn this as quite a linear, well, I've drawn it as a completely linear flow, one step after the other. But I'm sure we all know that in real-world applications, you tend to have much more complex workflows than that. You've got optional steps. Maybe you've got things that need to or can happen in parallel to save time, to help you move through that more quickly. Maybe you've got external approvals that need to happen, which we'll talk about later. So I know that this is just kind of the problem domain that I work in, but I'm sure pretty much all of us here have got similar examples that we could give of business processes where you have to go through a number of steps one after the other. And so the question is, can you make something like this using a serverless platform like Azure Functions? And the simple answer is, well, you could do it quite easily if you just turned every one of those steps in the workflow into a function and you triggered the next function with queues. Has anybody ever built a simple workflow using this technique? Okay, it's quite a common way to do things. So what we'll do is when the video is uploaded, we'll post a message into a queue, and that will cause the virus scan function to wake up and do its virus scan. And when it's finished, it will post another message into a queue, and that will cause the copying function to wake up. And when it's finished, post another message into a queue, and so on and so forth. And you could make that entire workflow that we just saw using this technique. And in some ways, it's got quite a lot of strengths to it. First of all, with queues, you've got the benefits of asynchronousness. You've got the benefits that quite often in queuing systems, if the thing that processes a message off the queue fails, that queue message will become available again to be retried. And so you get a bit of built-in retry. Also, we've said that Azure Functions scales out automatically. So if one of these tasks in the process was getting behind and was building up a backlog of queue items, it would automatically scale up multiple instances to help speed up that part of the process. However, this approach also comes with quite a lot of pitfalls. If you try and implement quite a complicated workflow using this simplistic approach of just saying, well, I'll just use queue messages to connect everything together, you run into problems. And so I'm going to go through what a number of those problems are, really just to help set up the case of why it is that durable functions is so interesting and what is there to help us deal with. So one of the first big problems is needing to see the big picture. When we take a whole bunch of Azure functions or any type of functions that are just connected together by queues, there's no one place you can go to in the code to see what is the whole big picture. So when I showed you this nice diagram, that was particularly easy for you to understand. There's nothing complicated about this because you can see in one place what the order of all the actions is going to be. However, if you've used a kind of a join everything together with queue messages approach, what you find is that you're looking at the code and you've got no idea really what's the thing that happens before me in the sequence and what's the thing that happens after me in the sequence. And so I have had in the past experience of looking at code that works like this and trying to draw out in my notebook what is actually the big picture so that I can understand what's going on. Secondly, you tend to end up creating a kind of a software version of a Rube Goldberg machine. And I'm sure most of you have seen Rube Goldberg machines or seen kind of more modern inventions of them, interpretations of them on YouTube, where people make these incredibly elaborate inventions. So in this particular example, the woman peels an onion, it causes her to cry, her tears flow down the pipe, it causes the scales to tip, that causes the bellows to blow, and the insects fall off, and eventually I'm not sure what eventually it will do, the weight will fall. And the reason these Rube Goldberg type inventions amuse us is because we can see that it probably could work if everything went perfectly. But if one thing goes wrong anywhere in the process, then suddenly we've lost track of where we were. And the end result doesn't happen at all. And so that's one of the problems that you very quickly run into if you just try and create your workflows using a simplistic queuing-based system. Somebody will say, I uploaded a video at 9 o'clock this morning, but I've not got my notification. Where's the problem? And so what you end up having to do is kind of trawl through logs and try and find evidence. Which of these functions actually run? Which is the one that it got stuck on? Another thing that you run into is that there are sometimes it's quite common really, in a cloud-based system, in a distributed system, there will be times where a transient error prevents you from successfully performing a step. And if you were to retry, then maybe it will succeed. And so the best practice generally, I don't know if have any of you used libraries like Poly in C#, which is a really nice C# way of implementing certain retry and back off patterns. You just say, I'd like to make this web request, but if it fails with a transient error, I would want to try again in a minute, and then try again in 5 minutes, and then maybe sleep for 30 minutes and then try again. Unfortunately, you can't really use something like Poly in Azure Functions. Azure Functions, because I said the pricing model is you pay for the time your function is running, first of all, you don't want to be sleeping in your Azure Function, because if I say I'm going to sleep for 30 minutes in my Azure Function, then I'm paying for 30 minutes of Azure Function. And the pricing model starts to become a lot less attractive when you have very, very long running functions. Secondly, kind of as a way of protecting you from yourself, Azure Functions kindly limit the maximum duration of functions by default to 5 minutes. So the idea is that functions are not supposed to be long running. They get in, do something, do it quick, and then exit. So you can't really put sleeps into a serverless platform like this. And implementing retry and back off just using queues is a little bit tricky. What you can sometimes do is send yourself a future scheduled message, but that's quite a lot of effort to go to. Another thing that you find if you try to implement a workflow like this just by passing messages to queues is that sometimes the steps in your workflow aren't actually all that quite as simple as that. So for example, imagine the analytics step in this workflow. We're going out to an external system that is able to do some kind of processing or AI on our video file. That might be able to do it really quickly and just give us a result. However, it might be a more long-running process. So we might submit a job to it, and then it tells us via some other mechanism later that it's finished. And so how are we going to wait for an external response for an external system? Typically, that's either done with polling, so you'd end up having to have a scheduled job that was polling to see if it was finished, or maybe it calls you back on a webhook to tell you that it's done. But the other thing that you run into is that sometimes, in the real world, you never get the response. You submitted the job to it, and it just never replied to you. So you'd also like, if you're waiting for an event from an external system in the middle of a workflow, to be able to time out in a sensible way so that you can carry on or recover in some other way. And then the final thing that's really hard to do, or part of this is really hard to do, is if you want to implement steps in your workflow in parallel. So for example, imagine that after I've transcoded a video, the tasks of voice detection, analytics, and extracting a thumbnail are all able to be done in parallel. Now, if I'm using queues on a message queue, I can easily initiate other jobs in parallel because I just post 3 messages, and those 3 other Azure functions will all run at the same time. What's much harder to do, so that's called fanning out. Fan in is much more difficult because if I'm saying I only want to send the notification when all 3 of those tasks have completed, what I have to do is when each individual one completes, I have to work out, was I the last one? And only if I was the last one should we carry on to the next step. And although it's possible to write that yourself, it's the type of code that us as developers often accidentally put race conditions in and either never proceed or proceed more than once. So it'd be nice if there was a framework that could solve a lot of these problems. And that's really where durable functions comes in. So durable functions, and I'm just going to skip over that slide for a minute. Durable functions is an extension to Azure Functions. So if you've got an Azure Functions project, you can just simply enable durable functions by adding a NuGet package, which is the durable task NuGet package. When durable functions initially came out, it only supported C#. It was based on some quite clever use of the await keyword in C#. However, JavaScript, when I wrote this slide, it was in preview. Actually, they announced, I think, at the event earlier this week that it's out of preview. So JavaScript support is also available for durable functions. It is also completely open source, as is the whole of Azure Functions. But one nice thing is I've been able to get one of my own contributions in. So a feature I wanted, I was able to submit to Azure Functions that came out in one of the recent releases. And a number of other features I've requested were released this last week. So it's a really great community in terms of being responsive to people's requests and accepting work from the community. Now, Durable Functions adds 2 new types of functions to Azure Functions. And the most important one really is what's called the Orchestrator function. And so in Durable Functions, their word for workflow is orchestration. Okay, so if you see the word orchestration, think of it's a workflow. And the Orchestrator function's job is to define what are the steps in the workflow. So in code, you're going to say what are each of the steps, what order they're in, and this is essentially how you're getting the big picture. So I said earlier, there's a problem with not being able to see the big picture of your workflow. This makes it really simple. You look at the Orchestrator function, you can see exactly what's happening in your workflow. However, the Orchestrator function is not allowed to actually do any work itself. It's purely to define the workflow. And all of the actual steps in your workflow are performed in what's called activity functions. So the orchestrator will call an activity function, and when that activity is done, it will decide what the next activity to call is, and so on. Orchestrators can actually call other orchestrators, which sounds like kind of overcomplicated inception, but actually does turn out to be quite useful when your orchestrations and your workflows start getting quite complicated. And so the orchestrator really is about calling other activities and deciding what to do next. One really nice thing about orchestrator functions is that they can handle exceptions that are thrown not just in the orchestrator itself, but by any activity in the workflow. And this means that you've got a single place that could deal with a problem that goes wrong no matter where it went wrong in the workflow. However, it's quite... there's a little bit of magic going on behind the scenes in an orchestrator function, and it does mean that you have to adhere to some very strict rules, and we'll see why later. But in an orchestrator function, you can't just do anything you like. Particularly, you can't do things like making calls to the database, or you can't even make decisions based on what the current date time is without doing it in a very special way. So your orchestrator function is really about defining the shape of the workflow. The thing I like about orchestrator functions is that I'm defining my workflow in code. I know that there are other cloud workflow platforms that are about visual designers, and you draw a flow chart. Azure Logic Apps works that way. Some people do prefer the visual side of things, but as a coder, I quite like defining my workflow in C#. The other type of function is an activity function, and these are much simpler. They're really almost exactly the same as regular Azure functions. And the activity functions, their job is just to perform a single step in the workflow. And so an activity function can receive input data, so the orchestrator can give it some useful information to tell it what it needs to do. And that input data can basically be any object that can be serialized to JSON. And an activity, once it's complete, can return output data, which is given back to the orchestrator, and the orchestrator can use that to make decisions on what to do next. And activity functions can use bindings, so just like when I showed you some example Azure functions earlier, which had bindings to table storage, activity functions can use those as well. So you typically, in your activity functions, if you're talking to databases, you're talking to other services, it's really easy to do that, and you can use the power of the Azure Functions programming model. Okay, one of the questions that you might be wondering is, if I've got something that's trying to help me manage the state of workflows, and I can kick off workflows and I can track where I've got to in the workflow and so on, where is that state being stored? Where's it managing it? And Durable Function stores all of its state in what it calls a task hub. And the task hub simply is a way of knowing what orchestrations are currently in progress and how far through we've got in them. And what it uses behind the scenes is an Azure storage account. So any of you who use Azure will be very familiar with Azure storage accounts. Storage accounts consist of blob storage for files, table storage, which is a very cheap and simple key value database, and queues, which is for messaging. And Durable Functions in particular uses tables and queues quite extensively to do its stuff. But it also uses an event sourcing technique. How many of you come across event sourcing? Okay, it's quite an interesting approach to storing data in a database. With event sourcing, you don't ever update a row in your database. So you're not using your database to store the current value. Instead, you're always appending another event of what's happened. And so to work out the current state, you have to read through all of the events that have happened. And so what Durable Functions will do as you're working through a workflow is it will say, this workflow has started, this activity has begun, this activity is completed, this activity has started, and so on. And so it's built up a whole record in its task hub of exactly what the path through your workflow was. And that turns out actually to be super useful. Another thing that Durable Functions does when you install it to your Azure Functions app, it will give you a REST API. And so the REST API basically adds a number of additional endpoints to your Azure Functions app. For example, you can query the status of a workflow. So if you've kicked off a workflow and you're wondering where's it got to, you can call this API, you can give it the ID of the orchestration. It's protected by a secret code, so it's not like anyone can call this. And you can actually ask it in that request, please give me the event sourcing history. So if you really want to know exactly what all the steps were, you can find that out. You can also send an event to your orchestration, and we'll talk about that in a minute. It's about, this is useful for where you're waiting for an external system. If you've submitted a job to an external system and it wants to then tell you that it's done, it's not likely to know how to call Azure Durable Functions directly. So usually it will call you on some other mechanism and you will then pass that message on using an API like this to your orchestration. And you can terminate an orchestration as well. Okay, so demo time. I've got, how much longer have we got? Are we all right? Still good to... They're not listening. It's all right. We'll carry on.
Yeah. Said they were going to be late, if anything.
Okay. So I made a very simple demo application, and the demo application that I've made is of a e-commerce website. So this is a website which is selling ebooks in my example. And the way that this website is going to work is that when somebody buys an ebook on the website, we're going to kick off a workflow that's going to go through a few basic steps to show off how Durable Functions works. And if any of you have ever implemented an online shop, you probably know that it's not a good idea to be the one yourself to take credit card payments. You usually delegate that to a third party. So Stripe is quite a common third-party payment provider to use on a website. And so when somebody buys something, they will submit their credit card details to Stripe, and Stripe will then call you with a webhook. And so when you get the webhook, that would be the trigger for you to begin your workflow. And so here in this simple example, we've got a webhook that's come from Stripe or whoever's handling our payments, and we'll kick off a Durable Functions orchestration. And the first step, we will save details of the order into our database, which is just going to be table storage in this example. And then I've got an optional step. I'm going to say that if the order is over a certain amount, maybe I'm a bit suspicious that it might not be genuine and they're going to try and ask for a refund, I actually want to manually approve that. So if the order value is over a certain amount, I'm going to email myself, and then if I approve it, then we'll progress. If the order's under that amount, we'll just progress anyway. And then for all of the things in their shopping cart that they ordered, we're going to generate a watermarked PDF for them because we're a bit concerned they might share it on the internet. And when all of those PDFs have been generated, we want to send them an email that's got a link for them to download it. And so that gives us a chance to see the fan out, fan in pattern in action. So here, I've got my durable commerce workflow, and I'll run this up. Okay. And I'm actually using this is a little bit of a trick that I sometimes use for demos with Azure Functions. Azure Functions has got a feature called Proxies, which just essentially allows you to proxy any incoming request to anywhere else. And so if I have a website that's associated with my Azure Functions, I will often use a proxy to proxy any incoming requests through to the actual web static resources, the HTML, JavaScript, and CSS, whereas all the other requests go through to the Azure Functions themselves. And the reason to do that is to just get around cause problems so that it appears to this website as though it's calling functions on the same domain. So this is about the limit of my web design skills. It took me a very long time to do. I did it with Vue.js, which is quite fun to use, and I was going to try and do a Christmassy theme to it, but I ran out of time because I spent so long trying to make this shopping cart thing work. But if we add a couple of items to our cart, and we look in the shopping cart, we've got a few items in the shopping cart, and when I click Buy Now, this is actually going to call an Azure function in my function app, and it's going to start the workflow. So I'll click Buy Now, and you'll see here, again, I don't know if I can make this actually give a larger font size. There we go. We can see that it's performing the steps in my workflow. So my orchestrator is called process order, and then it's gone through the first step, save the order to database. It's then gone back to my orchestrator to find out what to do next. And the orchestrator has decided that it doesn't need to get approval because this wasn't a high value order, and it's created the 3 personalized PDFs. Then it's gone back to my orchestrator function, which has decided now to send a confirmation email. And so if all has gone well, I should have the confirmation email, and I'm using a website called Mailinator, which is just kind of a throwaway email inbox. And so I sent the email to durablefunccustomer@mailinator.com. As you can see, the order has just come through. You can see the date time there. It's not smoke and mirrors. This was really just sent. This was actually using the SendGrid binding of Azure Functions. So if you've got a SendGrid account, you can very easily send emails with Azure Functions. And if I click download here, it will download the files that it's created in Azure Blob Storage. And as you can see, it's not particularly exciting. It's actually a text file, just saying what you ordered and who it was from. And I've got another page on this website which allows you to query the status of your order. And so if I follow this link, what this is doing, this again is going back to my Azure Function app, and it's looking up the orchestration for that order, and it's asking the durable functions, give me information about the status of that workflow. And so I can find out, for example, the durable functions runtime status, so that's saying that this workflow has actually run to completion now. It can tell me the last updated time, so that was the last time that the workflow took a step. As you can see, this only took 3 seconds to run through that whole workflow. And workflows can also store custom states. They can remember what their input data was, so I'm using that to show this information about who purchased it and what they purchased. And it can also an orchestration can also have output data, so I'm using that to store the locations of the downloads, so I can also download from here. If I go back to my shop and let's make another order, we're going to buy something. Should probably have implemented that this cart cleared itself when you bought. If I buy something else, it doesn't really matter. We can buy multiple things. This will require approval. So if I click Buy Now, and we look here, we should see process order. Oh, I'm not. Sorry? Okay. Scroll past too quickly, yeah. Needs approval for the order. And so if I look at my order status page, we'll see the orchestration is running. So this workflow is still in progress. And a workflow can have a custom status, and I've set that to needs approval, just as a diagnostic message. So if I go back to my Mailinator, I've got another email inbox, which is an email to the administrator. And the administrator gets an email saying, please, can you review this order for a certain amount? And so I can click on that and I can look at my admin console, which is another little page. I've got my website. And this admin console is showing me all the workflows that are currently in progress or completed. That's the one that we did earlier. This is a new one. So if I say approve, that will now start running again. If I go back to, it was this inbox, wasn't it? How do I exit out of that? We should now see this order comes through and we can download that item. And if we go back to the status page for that one, we can see now it's completed successfully. So that was a quick run through of how of what the demo scenario is. So the first thing that you tend to have is what's called a starter function. So again, because it's typically some other system that is causing the event that triggers your workflow, that other system is not going to know about durable functions. So Stripe, if they're your payment provider, they're not going to call the durable functions API themselves. They're just going to call a webhook. So typically, you'd have an Azure function that receives that webhook and then starts a new workflow. And so here, this is a regular Azure function, HTTP trigger. And what I can use is a binding to what's called a durable orchestration client. And the durable orchestration client is simply a helper class in Azure Functions that enables you to interact with your workflows. And so what I'm doing in the body of this is I'm deserializing an order object, which represents what they've ordered. In a real-world example here, you would also almost certainly validate the HMAC of the webhook so that people can't just call this endpoint to get free stuff from your shop. But then you would call start new async on your durable orchestration client, which is essentially saying I want to initiate a new workflow. And all you need to do is you tell it the name of the workflow that you want to implement. So here, process order is the name of the workflow. You pass it the input data you want to give it, which can be any JSON serialized object. And then it will tell you what the orchestration ID is. And that ID is important because you'll need that to query how far through the orchestration you are. You'll need it to terminate it if you want to. You can, however, if you want to, actually tell it what orchestration ID you want it to use, which can be useful in some scenarios. So let's have a look at what an orchestrator function looks like. And rather than showing you the orchestrator function for that entire demo that we just did, which is quite large and complicated, This is just a simplistic orchestrator, just to give you an idea of how they work and what they look like. So again, in many ways, it's a typical Azure function. It's a static function, and it's got a trigger attribute to say what triggers this. And for an orchestrator function, it's an orchestration trigger. And you bind that to what's called a durable orchestration context. And so here we can see the first step, get the input. So as I said, orchestrations can have input data that they're given. In this case, it's just the order, who's ordered what. So we receive that, and then we call the first activity. So call activity async, save order to database. That's the name of another orchestrator function. Again, I can give it some input data, so I'm just passing it the whole order, and I'm awaiting that to finish. And there's some real magic happening here, which I'll talk about after the pizza break. But if you're used to C# and you know how async and await works, it's not quite what you think going on here. But we'll just talk through the rest of this function for now, and then we'll do our pizza break, and then we'll go into more details of what the magic is. But here you can see I'm now looping through all the items they've ordered, and for each one, I'm creating a PDF by calling another activity. And finally, I'm calling a send email activity. So this is an example of a workflow that's entirely sequential. I'm not going to do anything in parallel here. I'm going to call save order to database. I'm going to call create PDF as many times as I've got items in my order. And then I'm going to send an email. This, as I said, was a very simplistic example of a basic orchestrator that's just calling several activity functions one after the other. And if you remember, I said that there's a little bit of magic going on here that might not be what you expect if you're used to C#. So if you were just as a regular C# developer to look at this function, it looks like it would just run for the entire duration of time that the workflow is running. However, we'd said earlier that with Azure Functions, you are billed for however many seconds your function runs for. And in this particular example, it only ran for 5 seconds, our workflow. But when we did the run through with the manual approval, that might have been several hours or several days. And we don't want this function to be running for all of that time. So actually, this orchestrator function doesn't run for the whole time. And the magic all happens with the await keyword. So what happens is we come in, first time we run this orchestrator, we get as far as this. When it does call activity async, what durable functions is doing behind the scenes is it's actually just posting a message onto a queue. So it's posting a message onto a queue saying we need to run the save order to database activity. And then when it hits that await keyword, what the orchestrator function does is it goes to sleep. It actually exits at that point. And it tracks the fact that it's how far through the workflow it's got into its event sourcing database, which is stored in its task hub, which is table storage. And then the activity function will run, triggered by Azure Durable Functions using queues as the mechanism. It runs through whatever its activity is, and when it's finished, it will post a message onto another queue that is going to wake the orchestrator up. And so when the orchestrator wakes up, because the save order to database activity function has finished, what we'd like is to carry on from here, right? But we can't, because that's not possible in C#. You can't just jump halfway into a function. So what it actually does is it starts at the top of the function again, and it runs through everything. It gets the input data for the orchestrator, which it knows because it stored that in the task hub. It gets to call activity async save order to database, and it goes, I can see in my event sourcing history that I've already done that, so I don't need to do it again. And so it gets past this first await. Then we go through these items, we get to another call activity async, create PDF. It hasn't done that yet, so it posts a message onto a queue. Then we get to an await, so the orchestrator function goes to sleep again. Again, in the background, create PDF will run, it will post a message back onto the queue. The orchestrator will wake up again, it will start at the top, it will go, I've done that, come through here, I've done the first one of these, go around the loop, I've not done the second one, and so on. So your orchestrator function is constantly going to sleep, waking up, going to sleep, and it's able to know how far through it got because of that event sourcing history. What does an activity function look like? Activity functions, as I said, are not particularly exciting because they're just normal Azure functions. They've got the activity trigger to say, tell Azure Functions that I'm a function that gets triggered as an activity in a workflow. And the type that you put that activity trigger against is the type of the input data for that function. So it will deserialize that from JSON. And then inside your function, you can do whatever you like. You're obviously allowed to have side effects in activity functions because they are only going to run the once, and you can return whatever object that you like, again giving information back to the orchestrator function. So one trick that you might want to do with activity functions is if your orchestrator function needs to know a value from config, that's another dangerous thing to do in an orchestrator because the value in config could change over time. So it'd be better for the activity function to read the value and return it so that it's then always the same every future run. So let's go back to orchestrators and see how we would do parallel tasks. So imagine I want to create those PDFs all in parallel. What I'd do in my orchestrator is I'd just go through the items in my order, and instead of awaiting call activity async, I'm just going to call activity async and save the result of that, which is a task of string in this case, into a list. And so what will happen is the orchestrator will go through this, say I've ordered 3 things, it'll go through around 3 times, and it will call activity async 3 times. So there are now 3 messages sat on the durable functions queue that is going to cause those activity functions to run in parallel. And then I do a task.whenAll. And if any of you have used the task parallel library in C#, you'll know that's exactly the way that you would run tasks in parallel in normal C# code. Your orchestrator, every time it runs, it could be running on a different server every time. Also, all of your activities could be running on completely different servers. And in fact, that is exactly what my next slide is going to try and highlight. So in an orchestrator function, you can put a try-catch block around call activity calls and catch exceptions, not that were just thrown in the orchestrator code, which hopefully you should almost never see an exception thrown by the orchestrator code because it's very simple deterministic code. But if your activity function, which could be running on a different computer, throws an exception, what the durable functions framework will do is catch the exception in the activity function, serialize it, and then when the orchestrator wakes up, it will be able to deserialize that exception, throw it, and so your exception handler can run. And that means that you're able to catch an exception that could have been thrown on a completely different computer in the orchestrator function, which is super powerful and pretty much impossible to implement using just the simple message queuing technique that we talked about earlier. The other thing is you can see there's an overload of call activity async called call activity with retry async, and you can pass it retry options. So you can say, I want to retry with 30-second intervals a maximum of 3 times. And you can actually also ask it to examine the exception type to make a decision on whether you should retry based on the exception type. And the advantage of this is if it calls that activity and it fails, it's going to do that 30-second sleep or however long you specify, but the orchestrator is not running for that 30 seconds. So we've got out of the paying for sleeping problem using this technique. You can also, all of these call activity methods have got equivalent call orchestrators. So if you're using that sub-orchestration feature I mentioned, you can retry whole sub-orchestrations, and you can also call sub-orchestrations in parallel. How is waiting for external events implemented? Well, again, in the example that we showed, we were waiting for an approver to approve an order. And so if you want to tell your orchestrator that it needs to wait for an event from an external system, you use wait for external event. Every event has an event name, and it has a data type associated with it, which can be any JSON serializable object. And my little contribution to durable functions was that this method also allows you to specify the timeout as a parameter. It used to be much more complicated to wait for an event with a timeout. But here I'm saying I'm willing to wait 30 minutes to receive this particular external event. And if I don't get it, I will return the string timed out. And that basically allows me then in my orchestrator to make a decision based on whether I got the external event or not, or whether I timed out. And so here you can see we're emailing the customer if the order was approved, but if not, we're going into some other activity that will do some kind of mitigation of that scenario. There is one limitation of storage queues has got a maximum length of time that it can future schedule a message for, which I can't remember what exactly it is. It's something in the order of a week. So if you want to have a timeout of months, you have to jump through a few hoops at the moment. And it's again, I've suggested some code on their GitHub repository of how they could work around that, which might make it into a future version of durable functions. How do you send an external event? So if your workflow is just sat there waiting for an event to happen, how does it know about that? Like I said, it's very unlikely that your external system knows about durable functions and knows how to send a notification directly to the workflow. You probably wouldn't even want that anyway. It's better to have a level of indirection. So your external system sends you a webhook or contacts you however it does that. And then you just have a regular Azure function. So this is just a regular HTTP triggered Azure function that, when it's called, uses the durable orchestration client, which is what we use to start the workflow in the first place. And we call raise event async, the name of the event and the data that we want to pass to it. And that will cause our orchestrator to wake up again, reach the point where it was waiting for an external event and make the decision of what it needs to do next. So that was my run through actually of all the code of durable functions. I've got a slide here on why would you want to use durable functions? What's the case for it? Hopefully I've made a fairly decent case for using it tonight. I like the fact that you get to define the big picture of your workflow in code. I like the fact that in the orchestrator you can handle errors wherever they occur in the workflow. And so you can have global exception handling. You can retry individual steps with backoff without paying for that waiting time. It makes it easy to implement waiting for external events with timeouts and parallel workflows, two things which are quite hard to implement if you've not got a framework like this. It also makes it really easy to track the progress of your workflows. Like I said, the fact that it's using event sourcing, although it's a slightly quirky way of storing information, it actually turns out to be really useful in this case because I can see a full audit trail of exactly every single step that my workflow went through. And so if something weird does go wrong, I can very easily work out exactly what's happened. You can cancel workflows, it's open source. And of course, because it's built on top of Azure Functions, everything that's great about Azure Functions, all the ways it can be hosted, all of the deployment tools, all of the app service features in Azure are all available to you in Azure Functions. Can you test it? Right, so that was another one of the kind of bonus things to talk about, unit testing of functions. So if we go back to the function app, I have added in this demo project, by the way, this is on GitHub. I'll try and remember to put the slide up with the GitHub link to it so you can have a look at it and play with it if you like. I have got some unit tests for the orchestrator. And because an orchestrator, if we look at the, let's look at the orchestrator. So here's my process order orchestrator function, gets the input, saves the order to database. If the total was over $1,000, then we request approval, sending the email. We wait for the external event. If it was approved, if it wasn't approved or we got a timeout, we send an email to the customer saying, sorry, we've not accepted your order. If we did approve it, we go through, we run the parallel tasks and wait for them all to finish, creating the PDFs, and then we send a confirmation email to the customer. And if something went wrong, we also send a problem email to the customer. But if you actually look at the signature of this function, all it's got an iLogger, which we can easily mock. It's got a durable orchestration context base, which is an abstract base class, which we can also easily mock. So all of the unit testing techniques that you use, so I use NUnit and MockU, but you can use whatever unit testing framework and mocking library you like. You can just write regular unit tests for this. So certainly on the unit test level, it's really easy to write unit tests for your orchestrators. Activities can be a bit harder because some of the bindings, like the blob storage binding, isn't easy to mock. And so it's really hard to write a unit test for your activity function if it's using a not easily mockable binding object. However, the second level would be to say, I want to do some actual proper integration tests. I want to actually run my function app, so you'd have to deploy an instance of it, which is actually very easy to deploy Azure Function apps. The app service plan has got lots of ways of deploying that are quite easy. Just zip it up and push a new version. And then you could literally just try calling orchestrations and check on their status. You might want to inject into your workflow some ways of mocking out things, though, because if you were really charging credit cards or if you were really sending emails or alerts to things, you might want to have a way that you can disable those for your integration tests, but still test that the whole steps in the workflow are working. Likewise, if there was an approval timeout, let's say that the approval timeout was a week, you wouldn't probably want your integration test to have to wait a week. So you'd want to have a way of injecting into your orchestrator some configurability of how long the approval timeout was. But it's certainly possible to set that up. Because I completely rewrote my demo application, I didn't finish testing it in time to deploy it to Azure. So we could deploy it now to Azure for the first time. And the way I'll do it is the way that you're absolutely not supposed to deploy things to Azure, which is just a right-click publish in Visual Studio. There are much better ways to deploy that you would use in a real CI/CD process. One of my favorite ways of deploying things in Azure is with the Azure CLI, which is a cross-platform command line interface that is super easy to use. So you can deploy this using that. But if yes, there might happen to be a Azure CLI Pluralsight course by me as well. So I need to right-click on my function project and click Publish. And, it still remembers where I published it to last time, okay? Because I did this, a version of this talk at a conference called Prognet, and so I published it from there. So it remembers where I published it to. However, that is all deleted now, so it won't be able to publish it. So a new profile. I want to create a new Azure Function app, so I need an app service to run it on. So Azure Functions, it can run on what's called the consumption pricing plan. That's where it's got the pay per second pricing model that we talked about. But you can also run it just on a regular Azure app service plan, which is where you're paying for a server per month. And one of the advantages of that, the disadvantage is you don't get the infinite scaling and the per second pricing model. But the advantage is your functions are running on your server. You're not sharing tenancy with anyone else, and you also have got a fixed price. And when you run in that mode, they also take away that 5-minute function limit because it doesn't really matter anymore. You can wait 30 minutes in your function and it doesn't matter. But if I say select new, create new Azure App Service, publish, it will go away and it will load my subscriptions, and it will suggest a ridiculous app name for me. it will pick a storage account because it needs a storage account for the durable task hub, and I can pick the hosting plan. The hosting plan is what I was saying. This is this Y1. It's not very clearly explained in this dialog, but that means the consumption plan. And I'm in North Europe, and I will create a new dev South Coast resource group. Always a good idea in Azure to create resource groups for the stuff you deploy. So create. Unfortunately, we probably won't have time to see this completely finished, because after I've created this, I will need to set up some app settings which have got my SendGrid secret key that lets me send emails, and also I would need to tell it where to find those beautiful web pages that I created, which I would also need to host in Azure, which I haven't done yet. So seeing as you're hovering, we'll probably stop there, but that is how you deploy a function app.